So we're going to look at vertical asymptotes. First of all, a function has a vertical asymptote where the denominator is equal to 0. So if we have a function such as f of x equals 2 over x minus 3. Now if you had to sketch that function, you would probably find that the domain of the function was stated, which is to say x can have any value. X is a member of the set of real numbers, but it cannot equal 3. And the reason that 3 is a forbidden value is because if we put 3 into the denominator, 3 take away 3, we get 0, so the function is undefined. Now, the equation of the vertical asymptote, therefore, is, so vertical asymptote VA, the equation of the vertical asymptote then is x equals 3. And that would get you 1 mark in a test. Now, what I'm going to do is to just draw a vertical line. Imagine that's the line x equals 3. So when we get round to sketching the graph of the function, things will happen on the left and right hand sides of x equals 3. The arms of the function will approach this asymptote. So what do we do then? Well, we're going to consider what happens as x tends to 3 minus. Now, what I mean by that, what we want to do is to pick a value just to the left of 3, such as 2.9. I'm going to substitute it in here. Now, a value just smaller than 3, and we subtract 3 from it, that gives us a very small negative value. So say 2.9 take away 3 is minus 0.1. So 2 divided by a small negative value gives us a large negative value, which is to say, to the left of the asymptote, x equals 3, we have a large negative value. So the function, now a large negative value means we've got activity down here. So if you imagine these are large negative values of y. Similarly, we're going to consider what happens to the right of x equals 3. So as x tends to 3 plus, which is, so if we take the value, for instance, 3.1, we substitute 3.1 in here, so 3.1 take away 3 gives us a very small positive value. So we've got positive on top, positive on the bottom, so our answer will be positive. But it's going to be large because we've got 2 divided by a very small number. So what I could say is that y tends to, what we're going to do is to say it tends to positive infinity. And I should really have put in here y tends to negative infinity. Now if you don't believe me, take up your calculator and try a very simple calculation. So 2 divided by a very small positive value, 2 divided by 0.00008, and you get a very large positive value. So how does that transfer to our diagram? To the right of x equals 3, y tends to positive infinity. So the graph looks like this here. This being very large values of y. Now that's all we have to do. Here's a second example. Now, it's the denominator that interests us. So what we want to do is to take the denominator and work with it separately. I'm going to set it equal to 0, factorise and solve. So that's going to be factors of 8, that'll be 4 and 2. we want a plus 2, so it'll be plus 4 and minus 2. X then, x minus 2 equals 0 and x plus 4 equals 0. So x equals 2 and x equals minus 4. So in fact, the vertical asymptotes are x equals 2 and x equals minus 4. And what we might have seen is this restriction here on the domain. You generally see that, which tells you straight away that is a vertical asymptote at minus 4, x equals minus 4 and x equals 2. So what I've done here is just drawn two vertical lines. This is x equals minus 4. This is x equals 2. Our function is y equals x minus 3 over, and I'm going to put it in factorised form, x plus 4 and x minus 2. What we want to do is to explore what happens to the function on either side of the asymptotes. So first thing then, as x tends to minus 4 minus, which is to say to the left of x equals minus 4. Now, when x is minus 4.1, say, we've got a negative value on top. Minus 4.1 take away 3 is negative 7.1, so it's negative on top. I hope everyone can see that this value here is going to be negative. So negative 4.1 plus 4 is negative 0.1. So we've got negative here, and negative here. Now two of the negatives cancel to make a positive. What that means is that y tends to negative infinity. So this value's negative, this is negative, and this is negative. These two multiply together to give us a small, very small positive value. So a negative divided by a very small positive value gives us a large and negative value. What does that mean? It means to the left of x equals minus 4 we have something like this, a large negative value of y. As x tends to negative 4 plus, so just to the right of minus 4, let's just see what happens. So let's say minus 3.9 then. Well, this is going to be negative. This is going to be negative, so these two negatives cancel to give us a positive. And this here is going to be positive. So minus 3.9 plus 4 is plus 0.1. So we have negative divided by a negative, that gives us positive, and another positive here. So y tends to positive infinity. What does that look like on the diagram? To the right of x equals minus 4, we have the curve tending to positive infinity. We now look at the asymptote at x equals 2, same idea. So a value just smaller than 2, let's say 1.9. Well, that's going to be negative. Say 1.9 take away 3, that's negative. 1.9 take away 2, that's negative. So these two negatives will cancel to give us a positive. 1.9 plus 4 is also positive. So all three are positive. That means y tends to positive infinity. So we have something like this. Now it looks very much as though we're going to have a minimum turning point here, but that's something that we would explore later on. At the moment we're just interested in what happens at the asymptotes. So let's consider what happens in this region here. So 2 plus 2.1. Now this here is still going to be negative. 2.1 take away 3 is negative. This is positive, and this is also positive. 2.1 take away 2 is 0.1. So these two are positive, this one's negative. It means the overall value is negative. So we have negative infinity. Now I hope you understand where the infinity is coming from. When we say 2 plus, it's a value that's very, very slightly larger than 2. So this here is a very, very small positive value. So whatever we have up here divided by a very, very small positive gives us a very large. So the last thing to do then is to have, so to the right of x equals 2 we've got negative infinity, function tending to negative infinity. So if it's something like that, negative infinity for y being down here.